the mean of a discrete random variable. Now, the things that I'm going to write here in the very near future are going to look alien to a degree. So just stick with me. The value of x is your first x, your second x, your third x, all the way to however many x's you have, x to the nth term. And then your probability of x would be the probability that the first x occurs, the probability that the second x occurs, and so forth, until you get to the last probability, the nth probability for the nth x value. And we've seen exactly that situation already. We just did a problem 14 with the cars that was set up exactly like this. This would be your x1, x2, x3, and so forth, and your probability 1, probability 2, probability 3. So we've already dealt with this thing. It's just kind of writing it out as a formula, I guess. Now, the mean of x, the mu sub x, is x1 times p1. So you're multiplying the value times the probability plus x2 times p2 plus x3 times p3, and so forth until you get to your last x and your last probability. That's what you do to get it. A little simpler formula written, although maybe not necessarily to interpret, would be the sum of all the x's times all the probabilities in respect to one another, I guess you'd say on that. We'll do an example on this here in a bit. And so we have mean of a discrete random variable. Now we need standard deviation. Of a discrete random variable. Is the square root of sigma x squared. So what that looks like is this. The square root of x1 minus mu sub x, quantity squared, times the probability of that first event happening, plus x2 minus mu sub x squared times the probability of that event 2 happening, until we get to x to the nth term minus mu sub x squared times p to the nth probability. I'll be honest with you, I'm not thrilled with this notation here. I don't think it's very clear. Or the sum of x to the I minus mu sub x squared times p to the ith term. Where I and n have a similar sort of idea. This is the nth term. This is the last term, and this is saying all the terms till the end. How's that for a little Chinese for you? Pretty good? All right. We'll put it to work for us, though. Wait a second to get caught up. That's it for the notes for today. As far as the notes go, now let's do a problem and see if we can make it make sense. Everybody ready? Okay. So the problem we're going to do is related to a problem you already did. 7.2 we did in the last assignment. I'm going to just make some get some reminders up here for it. This was the 3-child family. And we were looking specifically at girls. How many girls are in a 3-child family? Now, if you list it all out, you can have 3 girls, you can have 2 girls and a boy, you could have a girl, boy, and a girl, a boy, girl, girl, or you could have 1 girl and 2 boys, or a boy, girl, boy, or the dreaded boy, boy, girl scenario. Or possibly even worse if you're a parent, the boy, boy, boy. Actually, no, I think that'd be kind of fun. It'd be, you know, the fights that they'd have. That'd be entertaining, right? Hang on, hon. Let them work it out a little bit before they, before we go break it up. All right, so in this problem we had x and p, x being the number of girls and p being the probability of each occurring. So we had 3, 2, 1, and 0, and 1 and 8, 3/8, 3/8, and again 1 and 8. Now that leads us to the next problem, which is 723. It is on page, with all the other problems. So I passed it. 3 children. So this is the problem we want to work with, but using this information. So the first thing it wants us to do is it wants us to find the average of x, the mu sub x. So what's the expected number of girls is what this would be. So we would take our number of girls and multiply it times our probability. And add that to our next number of girls possibility, our next x, times that probability. And our next x times that probability, plus our next x times that probability. Now, as I'm multiplying these guys, 3 times 1/8 is going to be 3/8, plus 2 times 3/8 would be the same as 3/4, wouldn't it? If I do some reducing there, the 2 and the 8 cancel. Plus 1 times 3/8 is 3/8. And then 0 times 3/8 is 0/8, or 0. So what I get is 3/8 plus 3/8 is 6/8, right? So 3/4 plus another 3/4 is 1 1/2, or 1.5. Add those guys up. Probably would have been easier if I'd left that in eighths. So that would have been 6/8. So 3 plus 6 plus 3 is 12/8, 1.5. Yeah. So if you have 3 kids, what's the average number of girls you'd get? I bet you could have answered that without doing that. Is that right? I mean, we could have said 1.5, right? But this is the calculation for it, and this is how it comes up. So the standard deviation of x is square root of, get that up a little bit there, the first x minus how many we expect squared times the probability of that getting 3 girls is. So 3 girls minus the average number of girls we expect squared times the probability of getting 3 girls, plus 2 minus 1.5 squared times the probability of getting 2 girls, which is 3/8, plus 1 minus 1.5 squared times 3/8, probability of getting 1 girl, plus 0 minus 1.5 quantity squared times 1/8. And then we go to the calculator. Should we start with the square root, or should we take the square root after the end? Let's take the square root after. Can't forget it though. So I'm going to do some of this in my head. 3 minus 1.5 is going to be 1.5 x squared times, and 1/8 is 0.125. Plus 2 minus 1.5 is 0.5 x squared times 3/8, which would be 0.375. And here's where I need to get a little tricky. 1 minus 1.5 squared, I've got a negative, so I'm going to go plus. I'm going to throw some parentheses in there for that negative. Negative 0.5 x squared times 3/8. Decimal 0.375. Plus the last one, 0 minus 1.5. Since I've got another negative, I'm going to get some parentheses in there. So 0 minus 1.5 is negative 1.5 x squared times 1/8, 0.125. Oops. I think I have everything in there correct. So I'm going to go ahead and hit enter. And now I take the square root of that. .866. Good news is that matches my notes, right? Okay. So I've either gotten it wrong 2 times or I've gotten it right 2 times. So sigma x so if I were to draw that out as an example, we've got many 3-family households. The average number of girls would be 1.5, so 0 standard deviations away is our mean. And -1 standard deviation away would be taking away 0.866 girls, right? And 1 standard deviation away would be adding 0.866 girls. So my 1 standard deviation and my -1 standard deviation, this one would be 0.634 girls and 2.366 girls. So 68% of our families would fall between these two. I'm not sure that that was actually part of the question, but I think it's good to kind of make it visual again. It's been a while since we've done that. So, you got 4 problems up there. I've got some stuff to hand out, but I will be available for questions.